Hello, everyone. I'm Andreas, and I welcome you to another Disamtex promotional video about the wetting agent additives for the paint industry. Disamtex is an additive manufacturer based in the south of Brazil, and it is specialized in chemical solutions for the paint companies. So if you're interested to know more about us and our products, please check the description box below. Also, feel free to like the video, subscribe to the channel, and comment about your own experience in paints, and which additives you use, and so forth. Okay, shall we start? So wetting agents are surface active additives that reduce the surface tension between a liquid and a solid substrate. So in paints, they improve the spreading of the liquid coating over pigments and surfaces. So they facilitate pigment dispersion by helping the liquid phase penetrate and surround pigment particles. And this reduces defects such as craters, pore leveling, surface tension irregularities, and so on. So overall, wetting agents enhance color development, uniformity, and coating performance in general. A wetting agent reduces interfacial tension between pigment particles and the liquid medium, as I told you before. So the illustration down here shows the transformation of a solid air interface representing dry pigment surface into a solid liquid interface representing a pigment fully contacted by resin. So proper wetting allows the liquid binder to penetrate pigment agglomerates, displacing trapped air present there. So after wetting, dispersion and stabilization steps will prevent and reinforce the system, prevent reagglomeration of particles, and reinforce the quality of the system. And factors such as pigment polarity and resin polarity, the pore structure, and viscosity will all directly influence wetting efficiency and final film performance. So I'm going to show you a video so you can understand how a wetting agent works. Here we go. Excellent. Beautiful, isn't it? So you saw a liquid medium in a glass representing the binder phase of a paint system. And when pigment is added, it remains floating on the surface because the liquid cannot properly wet the dry particles. And this happens due to high interfacial tension between the pigment surface and the liquid. And once a few drops of the wetting agent are added, it rapidly reduces the surface tension at the interface, and as a result, the pigment immediately disperses and sinks into the liquid, demonstrating effective wetting action. Cool. So this table positions different Disamtex wetting agents according to chemistry, non-ionic, anionic, or blends, and performance level. So it implies that wetting capacity varies depending on molecular structure and interaction with pigment surfaces. Um, so the APEO-free indication reflects regulatory and environmental considerations in additive selection. That's really important today, isn't it? So um, non-ionic systems typically provide steric stabilization, while anionic systems add electrostatic repulsion. Um, and the chart reinforces that wetting agent choice must balance performance, foam control, compatibility, and regulatory compliance as well, right? And this image compares a modern synergistic wetting agent, our Dawette 690, um, with a traditional ethoxylated nonylphenol, 9.5 moles. It highlights how ethoxylation degree influences the hydrophilic lipophilic balance, the HLB ratio, and the wetting behavior as well. So the performance difference in color development suggests more efficient pigment surface coverage and dispersion. And reduced foaming, you see there, indicates better dynamic surface tension control during application. So the example also reflects the industry shift away from APO-based surfactants toward more environmentally compliant alternatives. Okay. And how do we manage to evaluate the presence of a good wetting agent? So the answer is through a rub-out test. And the rub-out test highlights differences in pigment dispersion and wetting within a coating film. So when part of a freshly applied paint film is rubbed, the mechanical action of rubbing improves local pigment wetting and dispersion. And if the original formulation lacks sufficient wetting agent, the rubbed area will show a noticeable color or gloss difference compared to the untouched area. And this occurs because poorly wetted pigment particles are more uniformly distributed after rubbing. So a visible shade change therefore indicates inadequate wetting and dispersion, an inadequate dispersion efficiency in the formulation. Okay, so I believe that's all from me, and I thank you for your kind attention again. I make myself available, and we hope our conversations can go further. So feel free to get in touch.